So today we will be discussing about pharmaceutical organic chemistry, and we have a program MLP, which will help you to get more information and more details regarding the various subjects in which you need to pay a certain amount, and then you can easily get access to everything related to whatever the subject you require for chemistry and other subjects also. Yes, students, you can share this link with your friends so that they can join and get access about this webinar, and they can also learn about this pharmaceutical organic chemistry. And to get access to this all notifications and all, you need to subscribe. So subscribe to this on YouTube, then you'll get good access to all notifications related to whatever the updates that is happening in our group. Okay, so here, like you might have been coming across this chemistry being little complicated and all, and quite difficult for understanding. So the simple things are that, like if you have a good basics regarding chemistry, it will become very simple, and you can easily get understand of it. And like for organic chemistry, it is going to be like one of the easiest comparatively, and it will be require simple minor basics that has to be kept in mind. Then you can easily get all the concepts in a better way. So share your this link with YouTube link with your friends so that they can join and they could also learn. To get updated, you need to subscribe and get the bell icon. Click on this YouTube channel. Then you will be getting the notification related to whatever the updates we are having, what is going on, and what subject is going on. You can get all the updates if you subscribe to our channel and get that notification bell icon. Click so that it will be updated you regarding whatever the new things we are going to update. So let us start with our concepts like pharmaceutical organic chemistry 1. So here, if we go towards the syllabus, like what this chapter consists of, this chapter, in this you have classification of organic compounds, and we need to study about common and IUPAC system of nomenclature of organic compounds, and then we have to study about structural isomerism in organic compounds. So here, let us move towards what are the questions like that has been asked in the starting concept. Then we will be getting into our tips and tricks how to get into that. If you go towards previous questions from this chapter, what that will be coming mostly, like they would be asking you related, like give the IUPAC name of the given structure. The structure will be mentioned, and they would be asking you about the IUPAC name. And next, they could be simply asking for 2 marks, like a homologous series, give example. In this, you need to define it, and then you need to give an example. Likewise, they might be asking few questions related to common system of our nomenclature of organic compounds. Okay, and then we have a structural isomerism that could be asked simply in journal. Structural isomerism can be asked, and sometimes they would be asking you about what are the basic IUPAC rules of naming organic compounds, and then even few questions like the functional group related question will also be given, where we need to type or tell about what is the functional group, and we need to give the structure, naming of any file, like it has not given an specified, so any file. So these are few questions like here, like we can see few more in which they have given 5 marks question for just IUPAC. Usually IUPAC will ask mostly for 2 marks or 3 marks. 5 marks rarely, but if it gets for 5 marks, it's good for you because it will be quite easy to give the name structure to the given name or giving it the name to the structure. So here it has given about 3-hydroxy, 2-pentanone, 2-methyl, 2-butene, 2,2-triethylhexane, and 4-methyl, 2,4-diethylhexane, and 4-heptane, 2-one, 4-hexane, 2-one. And next is about a question related to structural isomerism, and you need to classify them. Okay, so like structural isomerism, its types, and give one example. That's okay. And then another simple question is very general, like what are organic compounds? Classify them with structural examples. Okay, so this is also a quite common, like very simple question that has been asked, and mostly you can see that IUPAC related questions are coming a lot. Here you can see this 2 marks question, which is give the common and IUPAC system of nomenclature for first 5 carboxylic acids. Okay, we need to give them the name for first 5 carboxylic acids. And next question was related to explain chain isomerism with the suitable examples. Okay, and the last question is like, what is isomerism? Write the various types of isomerism with an example and write a brief note on structural isomerism. So these are few questions that has been asked in university question papers. Okay, so these are just not frame up that has been asked in the university exams. So you would be getting mostly structure related to questions related to the structure, giving the IUPAC name of the compound, or either classify them. In the isomerism, they are just simply asking you about the classification, different types of isomerism. Sometimes they might specify a specific type of isomerism. Like it could ask about what is geometrical isomerism, give example. Okay, what is E and Z isomerism, give example. Okay, so these are about the questions that could be asked in our exams related to this chapter. Okay, now let us see like what we need to have knowledge in this chapter, what things we should be keeping in our mind. Okay, so here first and foremost thing, like you should be having a little basic regarding carbon. Okay, so you should be having a knowledge related to carbon, its valency. Okay, like it is having a valency of 4. Okay, and let me just okay, so here if you go towards organic compounds and if you classify them, basically these organic compounds can be classified into 2 categories: open chain compounds, cyclic compounds. The compounds which are having straight chain without any branch, that are open chain compounds. Cyclic compounds, when there is a closed structure, those are cyclic compounds. Like again in open chain, you will get few compounds which does not have any branch. So they would be having more like a simple straight chain will be there in them, and in branch compound you will be seeing a few branching that would be happening in them, that will be seen. Coming to cyclic compounds, the cyclic compounds again can be divided into homocyclic, heterocyclic. Homocyclic means such compounds which are having only carbon and hydrogen. They does not have any other moiety in them, so that are regarded as homocyclic. Okay, and heterocyclic, when there is a compound or element other than carbon present in the closed ring, we call them as heterocyclic. And alicyclic, aromatic compounds will also be there. So let us take few example structures which will help you to understand the difference between here. So here you can see acyclic or aliphatic compound. So this is ethene, CH3CH3, straight chain, and you can see this is straight chain aliphatic compound, and this is a branch one, isobutane, which is having a branch on it. Likewise, we are having a few functional groups here, acetaldehyde, where aldehyde is a moiety present in them, and you can see here acetic acid, that is a compound which is having 2 carbon acids. Alicyclic, which means that the compound is having the closed ring. So here few heteroatoms are also being added in here. So then when the compound is having a closed ring, it could be aromatic or alicyclic. Aromatic again can be of two types. That is, if the aromatic compound contains benzene ring in it, we call them as benzenoid, like benzene, aniline. Aromatic compounds sometimes they does not have benzene ring, but still they obey aromatic rule. So that are regarded as non-benzenoid. Okay, so that's about a few like heterocyclic compounds such as furan, iodine, pyridine. Okay, so these are like classification of organic compounds, like what are the different types of classification. And then we need to mention few structures, like if it is being asked about, write the classification, give the classification of organic compounds, give you structures. So you can simply classify them and write one structure for each type. That would be simply easy for you to complete the answer correctly. Now coming to like sometimes they are asking about what is homologous series. Okay, so what is homologous series in which we need to write about sometimes they are specifying write the first 5 compounds of carboxylic acid. That is was one of the questions that has been asked related to homologous series. So first of all, you need to have the knowledge about the functional groups. Okay, so like you should be quite thorough with the functional groups. Like here I'm having this one. So like compounds when they're having double bond, we call them as alkene. And when they are triple bond, alkyne. When there are hydroxyl, alcohol. When there is oxygen connected between 2 carbons, we call those as ethers. And when there is halogen, 17 group element, chlorine, fluorine, bromine, iodine, if they are there, we call them as haloalkenes. Okay, and amines, when there is a amine like ammonia been attached, amine NH2O group has been attached to the carbon, then we call them as amines. And aldehyde, C double bond OH, that is an aldehyde. So you might be knowing about the suffix or prefixes. Alkenes will get ene, alkyne will get ine, alcohol, all, ether will get ether or methoxy or alkoxy sometimes. So we have this ketone, another functional group, one we will be having, and then carboxylic acid, in which we will be giving the suffix oic acid. Example is mentioned here, ethanoic acid, and ester. Okay, so that is O8 we will be mentioning, alkyl alkanoate, that is methyl ethanoate is the name for this example here. And amide, when there is C double bond O NH group present, we call them as amide. We will be simply taking how many carbons are there, and then we will be naming it as amide. Like one carbon, 2 carbons there, ethanamide. Okay, 1 carbon, methanamide. So this is about the functional group that will be there. So based on the functional groups, we are having this homologous series. Means alcohols will have their own homologous series. Ethers will have their own homologous series. Aldehydes will have their own homologous series. Ketones, carboxylic acid, ester. So if you see like what is the difference or what is this homologous series, it is nothing but a sequence of compounds starting from the 1 carbon compound to 2 carbon, 3 carbon, 4 carbon, which like if it is not having any functional group, we call them as alkenes. Like we're having methane, ethane, propane, all are alkenes. Okay, when double bond alkenes, okay, then again if they are having triple bond alkyne, when they are having halogen, haloalkane, we call them as. So alcohols, when they are having hydroxyl, OH group, when it is in present. So here is example mentioned here. First homologous is methanol, and second is ethanol, 2 carbon alcohol. So that is like third will be propanol, 3 carbon. Fourth will be butanol. Fifth will be pentanol. So this is about the homologous series. So if you have the knowledge about functional groups, you are quite thorough with what functional groups, how they have been mentioned, how they have been attached, then you can easily give the homologous series of whatever compounds that is being asked. Like for example, carboxylic acid is being asked. So here you can write about uh, methanoic acid, then ethanoic acid, propanoic, then butanoic, pentanoic acid, like that. Okay. Now coming to next is esters, when they are having C double bond O and oxygen attached in that. So those are esters. Okay. So then again they would be having a group of compounds that are being there of esters category. Likewise, we are having amides in which CONH2 will be there. So it is methanamide. This is ethanamide, two carbon compound having CONH2. Then we are having nitroalkanes, alkanes having nitro group, nitromethane, nitroethane, nitropropane, like amines, okay, methanamine, ethanamine, propanamine. So it is about homologous series. And what is the basic thing or the difference between the next compound to the homologous series is they only differ with a CH2 moiety, the carbon, hydrogen, and H2. Okay, so they differ only with the CH2 moiety. So that is the difference you will be getting with the homologous series. Okay, each the next coming compound, if you simply add CH2, it will become the next homologous of the series. Now coming to this common tribal names. So here in organic compounds, there are certain names that is being given which does not have any IUPAC related ruling and all. They would just simply given certain names to them. So that are common names that are not IUPAC related names. Like for example, formaldehyde is there, acetone, chloroform, like acetic acid. Okay, like if you go towards IUPAC, name of acetone is propanol because it is a 3-carbon containing ketone. Like acetic acid, if you go towards its uh, IUPAC naming, it would be ethanoic acid. It is a 2-carbon compound containing carboxylic acid. Then benzene, it is actually 1 comma 3 comma 5 cyclohexatriene, in which in cyclohexane there are 3 double bonds. So that is what the IUPAC name for benzene, but we'll call it simply as benzene. Anisole is methoxybenzene. We call it as anisole. Aniline, uh, like aminobenzene, we call it as aniline. And then acetoxy like benzene is acetophenol. Likewise, mentioning about ethyl, methyl, ether. Okay, so that is also a common naming system. So these are the names which has been mentioned, like isobutane, neopentane. Okay, so compound of carbon having 4 methyl groups attached to it. That is called as neopentane. Okay, then we are having N-propyl alcohol. Okay, so that is like in IUPAC system, we are having that suffix ol all will be added. We won't mention like propyl like that. We will be giving that propanol as IUPAC naming. Okay. So this is about the common name. Usually the common name system won't be asked much, but it has been asked. It's not like it never asked. They will be asking about write a note about the common or tribal naming system with examples. So in which you can give this few examples in which where the compound has been not given the name according to IUPAC rules. Simply it has been given a specific name and that is being used commonly, like acetone commonly used, acetic acid, anisole, aniline. These are very much used in usage commonly. Okay. Coming to this IUPAC ruling system, in which we need to follow certain rules to give a name to a structure. Okay, so here, first step that we should be keeping in mind is determining the primary function group. So we have seen that there are various functional groups that are present. So we need to first determine what is the primary function group, and second step, determining the primary carbon chain. Okay, so what is the number of carbon chain, and then third step is naming the primary carbon chain, and then fourth one, numbering the primary carbon chain. Fifth, indicating the position of the primary functional group. And sixth one, naming the substituent. So first we need to do is, we need to identify which functional group it is there, that either alcohol or ethanol, like ketone, carboxylic acid. What is the functional group that is there? We need to first identify it, then determine the primary carbon chain of it. Then we need to keep the naming for the primary carbon chain, numbering to the primary carbon chain. Then we need to go towards functional group, like what position the functional group is getting. And the sixth step will be naming the substance. So let's take an example here. Like we are trying to give naming for an alkane as well as an alkene. These are the line structures. Okay. So here, first of all, what we are doing is we are identifying the parent chain. And for that rule is we should consider the longest chain. Okay. And the longest chain should include the functional group. So here you can see here, for this compound, we are not taking the straight chain, we are taking the curved chain because here also there are two compounds are there, and here also there are three. Okay, so we would be considering this 1, 2, 3 as the chain instead of this one. Okay, now we got the longest chain. We need to identify the substituents. What are there? Okay, and what else we need to do now? Numbering. We have identified, and numbering we need to select properly. How? Like you can go from left side here 1, 2, 3, 4, 5, 6, 7, 8, 9. We are getting second and sixth as the substitute. If I started from here 1, 2, 3, 4, 5, 6, 7, 8, I would have get 4 and 8 for these substituents. So here we need to get the substituents on the smallest locants. That is important, and that will help us to uh, identify or give the proper IUPAC name. So here also you can see here, you can just see the difference. Like the compounds are quite similar, but the numbering system and longest chain is getting different. Why? Because of the substance to get the least number. That should be considered. Here you can see this is a branch. It is not a functional group like methyl branch. But here it is an alkene, a functional group. So that functional group has to be given the priority. So this functional group has to be given the priority. So we are starting the numbering from here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So double bond C should get the smallest number. Now, what we are doing, we are paste the substance alphabetically. We know that methyl, single carbon, methyl, two corners are there. So it is ethyl. So here having ethyl and we are having methyl. So it is not based on a smallest from the longest ascending, descending order. It is not there. Alphabetical order. Which comes first? E comes first, then M. So we should be mentioning, irrespective it is on 6th or 2nd, that you should keep in mind. Like it is on 2nd, I should write first. No, you should see alphabet. E come first, then methyl. So you should be selecting the E and write it first. Whatever the substituent number is there, no problem. So 6 ethyl, 2 methyl, no name. 9 carbon compound, no name. One more thing you should keep in mind, you should be quite perfect with the starting 10. Meth, eth, prop, but, pent, hex, hept, oct, non, dec. These are the 10 compounds. Okay, so that 10 basic carbon names you should be having perfectly remembered by hearted. Then you can easily give the name. So here you can see in this we are having on third position 1, 2, 3 propyl is there, and on 7th position methyl is there. So if you see alphabetical order, M comes first, then the P. Okay, so that is why 7 methyl, 3 propyl, oct, 1 ene, or oct propyl, 1 octane also you can write. Okay, so we are writing here as, select this as the, for example, name properly, like 7 methyl, 3 propyl, oct, 1E. Here it is given few more examples, little bit larger, okay, where we are having more substituents. Okay, so here you can see the numbering starts from this compound. Here 1, 2, 3, and 4. Okay, so the benzene, when it is being considered as a substituent, it is called as phenyl. Okay, and this is bromo, that is alkyl, like halide, and these are methyls. So here if you go towards phenyl B, bromo B, and methyl F. So if you go towards the alphabetical order, bromo comes first, then methyl, then phenyl. So here in this example, you can see there are two methyl groups on the same carbon. So some people or some students might do a mistake. What they do, if there are two compounds, they would be writing three dimethyl. That would be wrong. If the compound is having methyls twice, you should mention that number twice. Like it is 1 bromo, 3 dimethyl, 1 phenyl. How many carbons for the parent chain? 1, 2, 3, 4. Butane. Okay. So another example we are taking a little bit simple. So here 1, 2, 3, 4, 2 bromo, 3 methyl butane. Okay. So it has been given an example of differentiating between primary alkyl halide and secondary alkyl halide. Like when the branch of bromine is on first carbon, primary. When it is on the middle carbon, it is called as secondary. And we are taking one more example here. Little more branching is there. Here you can see instead of methyl, we are having ethyl, okay, on the second carbon. Uh, and here you can see that the carbon chain would be going little different. How it is? So here we are taking 1, 2, 3, 4. This one is our carbon chain. Okay. So if you take this one, because we need to consider bromo, so we can't go with 1, 2, 3, 4, 5. 5 carbons we can't go. We can have to include bromine, but with the longest. If you go straight, only 3 carbons. If I go either this way or either this way, I'll get 4 carbons. So 1, 2, 3, 4. So this is the way we will be moving. So on second position, you're having ethyl. First position, bromo. And you're having a methyl on the second position. So 1 bromo, 2 ethyl, 2 methyl, butane. Okay. Coming to another example here, where we are taking another example where we are taking pentane. Okay, so 1, 2, 3, 4, 5. Again, we need to pent because it's not necessary that always you should be considering the straight chain. You should consider the longest chain. Okay, so here we are having considering the longest chain with the 5 carbons. That is, pentane is our longest chain. Then we'll be having this chloro at the third position and methyl at the third. So 3 chloro, 3 methyl pentane. Now, coming to next example in which we are having a double bond. Okay, so double bond also quite important. We need to first see that which side the double bond is coming the nearest. If I started from this side, on the right side, 1, 2, 3, 4, it would have started with the 4. So I should start with this side, 1, 2. So we can get that on the second position. Then others will get the respective numbers. Okay. And one more thing, when giving the number to our alkene, you should consider the number where the double bond starts, not the third, because it is connected between second and third, but the number should be given for the second, where it is starting, where the double bond is starting. So it is third position is having chloro, fifth it is having methyl, and second position is having the double bond. So it is 3 chloro, 5 methyl, hex 2E. So it is an example of vinyl halide. All right. So this functional groups we have seen because these are the basics you should be having. If you don't thorough with the functional groups, it's quite difficult for you to give the impact system. Okay. So here it's quite a fun part here where I have mentioned about alphabets. And these all alphabets can also be given the IUPAC name and based on the line structure part. Like simple, I think the ninth one is the most simple. And what it is, it's ethane, two corners, two carbons. It is ethane. Okay, and little more simple compounds. Third one, C, 1, 2, 3, 4. It is having four corners. It is a butane. And if you go towards 11th one, it is also quite simple. 1, 2, 3. It is propane. And let us move towards more simple. Look here, 22nd one is also propane. Just the way of mentioning is different. Okay, and 26th one Z can be also 1, 2, 3, 4. It is a butane having the four corners. Okay, this one is also a butane having the four corners. So likewise, every compound, every alphabet which has been mentioned can have its own IUPAC name if you consider it as an organic compound. Okay, so like here I've mentioned, like for example, uh, A, first one, it is a 1,2 dimethyl cyclopropane. Okay, and oh, this one I think I even can guess. It is four corners compound cyclobutane. Okay, so likewise you can get if you just try to give, like one of my student has wish me happy birthday, like happy Teachers Day, sorry, on 5th with writing this whole IUPAC names of that whole happy Teachers Day, and I still have that in my Insta that thing, so that it like it, like they are using this concepts and they are trying to get it easily. Okay, so here you can see if you try to do this one, like 11th one. So if you go towards the 11th one, it is 2,2 dimethyl propane. On second position, 2 methyls. It's quite simple. It looks little difficult. One corner, 2 methyls, 1, 2, 3. It is a propane. Okay. Can you name this one? 1, 2, 3, 4. It is like 1 comma 3, sorry, 2 comma 3 dimethyl butane. Now, there are certain cyclic compounds are also there, which would also have a common names, because common names we are having with benzene related compounds, we are having a lot of common names that is being mentioned, like benzene, that is also a common name. It is not the IUPAC name. IUPAC name, we need to mention it as a cyclohexatriene. Coming to toluene, when benzene is having methyl, phenol, when benzene is having hydroxyl, aniline, when benzene is having NH2, anisole, when benzene is having OCH3 onto it, benzaldehyde, when the benzene has C double bond OH, benzoic acid. Okay, it is like having a C double bond carboxylic acid moiety, benzoyl chloride, benzyl chloride, zoyl when it is having C double bond OCl, oxychloride when it does simply have CH2Cl, methyl chloride, we call it as benzyl chloride. Just the O difference creates a lot of difference here. C double bond O, we call it benzoyl. Okay, acetophenone, benzophenone, naphthalene, and heterocyclic compounds such as pyridine, pyrrole, furan, thiophene, pyrrolidine, morpholine, tetrahydrofuran, piperidine, imidazole. These are certain common names. Actually, why this common names has been mentioned, because we will be studying them as their common name mostly rather than their IUPAC name. It is not of the most importance for them when you study. Like when you're going to study about benzene, you will be studying about a benzene as a benzene. You won't mention its IUPAC name while studying about it. And like heterocyclic compounds, when you're going to study, you will study them as pyridine, pyrrole, furan, thiophene, imidazole, like that. Okay. So here it has given certain a few nomenclature for cycloalkenes, like how to give the cycloalkenes the nomenclature naming. So here, for cyclic compounds, it is quite simple. If it is alicyclic, means doesn't have any functional group, doesn't have any double bond, single bond, then you will simply write cyclo and you will count the number of carbons. So it is like cyclo, one corners, 1, 2, 3, 4, 5, 6, cyclohexane, right? It's quite simple. But the changes occurs when there is a functional group. Like if there's a functional group, single functional group, like for example here, double bond is mentioned in this one. So it is having a single double bond present in it. So when there is a single double bond, we don't need to worry about the numbering because always it will be considered first. So it is cyclohexene, no numbering. But if there is another substituent along with this double bond, at that time you need to give the numbering and you need to give the priority to our double bond. Okay, so you can see here, if there is no double bond, the priority would have been given to the branch, this methyl cyclohexane. As soon as the double bond comes in the structure, double bond takes the priority. You'll be having 1, 2, 3, 4, 5, 6. So here, methyl, like 5 methyl actually it is 5 methyl cyclohexane. Okay. What is the numbering direction also? That is also important here. Okay. So here, name, it is coming if I write here 5. But what is the name mentioned here? 4-methyl, which means that this numbering is not correct. It has to be like we can go either clockwise or anti-clockwise. So we should see that we should move in such direction so that we should get the shorter. Like if I go anti-clockwise, I'm getting the methyl branch on 4th position. If I go clockwise, it was getting on the 5th position. So this direction, whether to go clockwise, anti-clockwise, that also important because lowest number rule was there for our straight chain compound. Same thing is there for these also. We need to have the lowest number that we need to select. So if I go anti-clockwise, it is coming on the 4th. So it is 4-methyl cyclohexene. X1-ene is the correct type. This is not the proper numbering. Numbering should be 1, 2, 3, 4, 5, 6. Okay. So this is an example. And bicyclic, it is also important for your competitive exams, like how to name the bicyclic compounds. So here, bicyclic compounds, we need to again, first of all, side we need to draw that. And then we need to separate the bridge which is connecting and creating that two cycles. Okay, and then we will be selecting that chain and we will be giving the number 1, 2, 3, 4, 5, 6. Okay, and the bridge, if it is having one carbon, so we give it as that number, last number 7. So it is 7 carbon containing compound. That is one thing we need to do. Okay, so it means that it is an heptane. First of all, we need to calculate the number of carbons. We have calculated 7 carbons, heptane. Now, what we should do in this, because it is two cyclic structures are present together, so we call it as bicycle. Now, in the bracket, what is this 2 to 1? How we would write 2 to 1 means excluding the bridge carbons. Means first and fourth carbon are bridge carbons. Excluding that, how many carbons left? There are 2 carbons left. 2. Okay. On the other side, how many carbons left? 2. 2. In the bridge, how many carbons are there? 1. It's not necessary that there should be any carbon. There are certain times there won't be any bridge. Like here in this last example, it is a fused string. So here on this side it is having 4 carbons. On this side it is having 4 carbons. In the bridge it does not have any. So we mention 0. So 4, 4. Total if we calculate 10 carbons. So bicyclo 440 decene. Got it? Now, how to select which to be right? There are 2 sides, right? Which has to be given the priority. the larger size. Here you can see in this example, it is having 1, 2, 3, 4, 5, 6. Okay, so we need to select the longest side for the numbering again. Okay, and then uh, we should be selecting. It is having two sides, it is having one side. What number should come first, 2 or 1? The longest number should come first. Bicycle 2, 1. In the bridge again 1 is there. So 1 Acing. Okay. Now let's move towards this example. In this, both the sides are having 3, 3. Total number of carbons are 9. So it is a nonane. Two cyclic compounds are like two closed rings are formed. So bicyclo. One side excluding the bridge carbons, 3 are there. So 3 on this side also 3 are there. 3 on the bridge, 1. So 3, 3, 1, non-name. Right? So this is a little bicyclic ring system. So it is quite important for a competitive exam. It is also quite simple. Just you need to have draw a side view, which will help you to identify the branch, how the bridge is being connected. Then you need to select the numbering proper. Like if it is a same, no problem with the numbering. When there is large and small, prefer the large one. And when there is fused ring, the last number will be 0. Last number 0 indicates it is a fused ring. So that's about the nomenclature. So we should be having a basic regarding functional groups, and you should be having basic regarding the basic tribal, basic numbering of the names, the methyl, ethyl, all those things you should be having. So it will become very simple to write the IUPAC name. Okay, you might be having this bicycling is also quite simple. Usually, after seeing the name, drawing the structure, it looks quite difficult, but it is very easy when you learn it, if you get that concept. Now coming to isomerism, okay, we are having apart from the classification of organic compounds and then nomenclature part, we are having the concept of isomerism. And in this isomerism, the isomerism is nothing but compounds having the same molecular formula, but they would be having a different structure. So that is what isomerism. Okay, having same molecular formula but different arrangement of atoms in the compound is called as isomerism. So here, isomerism basically it would be divided into two types: structural isomerism and stereoisomerism. Structural isomerism means when there is a difference between structural arrangement, we call it as structural isomerism. Stereoisomerism, it goes towards the three-dimensional arrangement, 3D structure, where it is goes to a stereo. So 3D structure differences comes into the play, where we are having geometrical and optical. Actually, E and Z is nothing but our geometrical isomerism. R and S is our optical isomerism. So that will be there in stereoisomers, where how the arrangement is differ within the space in 3 dimension, how they are different. So that is coming to structure. But in the exams, the question has been asked simply sometimes about the structural isomerism. Okay, sometimes when the question paper, they might be even specifying the write an example or give a note on positional isomerism, or write an example for functional isomerism. They might specify, but usually they won't specify when they are asked for 5 marks. They will generally ask you about write a note on structural isomerism, in which you need to write about the different types of structural isomerism, and then you need to mention, like, whenever you're writing about the isomerism and all, never forget to give an example of a compound. Okay, the example is must. You should draw the structure, you should give an example, then only your answer will get that weightage. If you are just writing the theory part and expecting more marks, then you won't be getting that. If unless you draw the structure, specify how it is differ, then because these are like structural isomerism is a very simple way of getting the 5 marks if it is being asked for 5 marks. Okay, so like in the first is chain isomerism, in which the compounds, whether they are straight chain or branch. So that is quite simple here. Pentane example has been given. Then we are having 2-methyl butane, and we are having 2,2 dimethyl propane. All three are having different IUPAC name, different structure, but if you calculate the molecular formula, all will have C5H12, means 5 carbons, 12 hydrogens. That is the difference of that will be there in chain isomerism. Position, like functional group will be same, right? And then that functional group, look here, chain isomerism does not have functional group. That you should keep in mind. Simple hydrocarbons without a functional group might have this chain isomerism. When there is a functional group, they would be having the positional isomerism, where the functional group will be same, both are alcohol, but the where the position of alcohol is there, that is different. So that is butane 1 all, butane 2 all. Okay. Another is functional group isomerism. This is very important. Okay. Here what happens? Molecular formula. If you calculate how many carbons, hydrogen, oxygen are there, that will be same. But functional group will be different, and their properties, physical appearance will also be different. Their nature will also be different. So here it has given the alcohol and ether. So if you compare, the boiling point of alcohol is nearly 60, 70. For ether, it is 30 something. Okay. So here the boiling points are differing. Here it's alcohol, just because the position of the oxygen here in ether, it is between the two carbons. Here it is at the end. So it is becoming a total different functional group. The physical properties, appearance, odor, everything will be different for these. But if you see the number of carbons, hydrogen and oxygen, that will be same. Coming to next is tautomerism. We call it as sometimes ketoenol tautomerism. That usually happens when the compound having ketone. There is a possibility that they will interchange the position of the double bond. Okay, so what happens? This ketone, acetone we have taken. So the methyl, which is having CH3, 3 hydrogens, it can migrate its oxygen to this hydrogen to this oxygen and make it alcohol, and it will take up the double bond. Enol is nothing but an alkene which is having an alcohol attached to its double bonded carbon. That is enol. Alkene, to which alcohol hydroxyl group OH group is attached to the carbon bearing double bond. The carbon which is having double bond, it should have alcohol. If it is there somewhere else, it is not an enol. Enol means it should be double bonded carbon should have the alcohol. Okay, so that is a tautomerism. And here it has given about ENZ isomerism. Okay, so here where we will be giving the uh, priorities. Okay, and uh, Z, you should be remembering. Here's example is quite simple, in which we don't need to have the priority concept, but I'm telling that Z has come from the word Zusamen. Zusa means it is Latin word which means same. Okay, when the same compounds are present on the same side of the double bond, that is called as Zusamen or Z isomer. And basic representation is cis. We call it as cis or Z. E is nothing but antigen. Antigen is the word from where this E has come, which means opposite. When the same compounds, like same groups, when they are present on the opposite sides, we call it as antigen or E isomer. So here it is about isomerism, E and Z isomerism, and coming to RS isomer. Okay, so RS, this is optical activity. We are having a concept of that where we need to study about optical activity. We are having chirality. There are certain parameters that should be followed for a compound to be or an aromatic to show optical activity. Okay, say it should be having 4 different compounds attached. This is the basic thing. Like sometimes I might be, they might be question on multiple choice. They might be asking about like how many, like whether this compound is aromatic or not. Identify which compound is aromatic or not. In that example, draw the structure. See that if a carbon is there, which is having 4 different things attached, or 3 different, hydrogen will also be there. Always hydrogen will be there. Apart from that hydrogen, how many branches are there? Whether it is attached to another carbon, then 2 or different molecules are there, then that compound will exhibit optical activity. Because when it is having 4 different compounds attached to it, there is a possibility that it could have 2 different types of arrangement and it would show optical activity. So it has given R isomer, S isomer. Okay. So here again R, when you're moving in clockwise, S anti-clockwise. Like again, we need to remove the hydrogen and we need to go towards the priority. So here fluorine to chlorine, bromine, anti-clockwise. We need to go. For here, bromine, chlorine, fluorine, chlorine, bromine, clockwise we need to go. So R isomer, clockwise, S isomer, anti-clockwise. So that is the way of arrangement. We will be giving the numbering 1, 2, 3, 4, and we'll see how the numbers goes on priority wise. Then we'll give the assign S isomer or R isomer. In optical, we also have this like levo-rotatory, dextro-rotatory, plus and minus. We will mention in that. Levo and dextro, like when they are deflecting plane polarized light in right direction, we call it as levo. Right direction it is dextro, and left direction it is levo-rotatory. Okay, and we also have this relative configurations. Okay. So here it has given you more examples here. Conformers and rotamers. Okay. So where we will be having this ethane, it would be having different conformers will be there, and cis and trans isomers, diastereomers, enantiomers, in stereoisomers. You might be have listened to the not having the might be have come across this word diastereomers, enantiomers. You know the difference between diastereomers, enantiomers? Enantiomers are non-superimposable mirror images. Okay, so those are enantiomers. Diastereomers, these are also non-superimposable but non-mirror images. They are not mirror image, but enantiomer they are mirror images of each other. So that is the difference between diastereomers and enantiomers. Both are non-superimposable; they don't superimpose on each other. But diastereomer is not a mirror image. Usually, you can't see this diastereomer when the compound is having only 1 carbon. When the compound is having 2 carbons, more than 2, 3, 4 carbons, then you might be having this diastereomer concept coming across. So here, what you should be going through, like for getting this structures perfect, correct, and mentioning about. Like, let us move again towards our previously asked questions. So here, it has given this name for this compound having CN. Okay, so CN is for cyanide, and we also call it as nitrite. Okay, cyanide as well as nitrite. So here, let us try to name this one. 1, 2, and let us write this CH2, CH2 taken twice. CH2, CH3 it should be. So it is having to this compound. Right. Now let us hydrogen, and this is our cyanide, Cn. Let us write this hydrogen first for that. For this also. Right. Let us give the identify our functional group as cyanide, or let me take it as nitrite. The difference between cyanide and nitrite, when you doesn't consider the carbon, we call it as cyanide. Okay. When you consider the carbon, we call it as nitrite. So here, numbering starts from this carbon: 1, 2, 3, and 4. So it is on second position. What it is having? Ethyl. So it is 2-ethyl. How many carbons? 4. If I give the numbering based on cyanide, like let me give you the numbering based on cyanide. So it will be 1 cyano, 1 cyano, 2 ethyl, butane, okay. So 1 cyano, 2 ethyl butane would be the name if it is you're considering the cyanide. If you're writing it as nitrite, what would be giving? We would be calling it as 2-ethyl butane nitrile. Okay, sorry, for cyano, we would be mentioning propane because we would consider only the 3 carbons. When cyano, this will be propane. So that difference will be there with the cyano and nitrite. When you write nitrite, this carbon will be considered and you will be taking it as butane. Okay. So that mistakes many people might do. So remember that if it is having cyanide, if you want to mention cyano, don't consider the carbon of the cyanide. If you write as nitrite, you need to consider the carbon. So you need to write butane for nitrite, propane for cyanide. Okay. So like homologous series, I think what are homologous series give example, we can easily now write about the different homologous series of alcohols, carboxylic acid, then we can write about halo compounds. Okay. Now, what you understand by term functional group? Functional group, like giving the specific property of the hydrocarbons that is given by the function. Like you might be knowing acid, carboxylic acid, they have a characteristic feature. Alcohols, like they have a characteristic feature. So that is determined by their presence of the function. So you need to give the names of 5 important functional groups, simply aldehydes, ketones, carboxylic acid, and esters, ethers, like this you can mention, give example for them, and then you can complete the answer. Okay, everywhere, wherever uh, required, mention about the examples. Okay, next about like write the common system of nomenclature of organic compounds. We have seen that tribal naming, common naming, common system is not there. Usually, IUPAC system of nomenclature is there, but there are compounds which are having tribal names. like formaldehyde. It is a tribal name. Okay, H COOH. So this compound gets a common name formaldehyde, and if you go towards IUPAC name, it is methanoic acid, one carbon compound containing carboxylic acid. Okay. Now it has mentioned another easy, simple question by which you can gain all the 5 marks, like explain different types of structural isomerism with example. Mention about like chain isomerism, positional isomerism, and function group isomerism, tautomerism. Okay. Next is describe the IUPAC main rules of naming of organic compounds. So you should be taking down this 6 rules, determining the primary function group, determining primary carbon chain, naming primary carbon chain, numbering primary carbon chain. Last, second step is indicating the position of the functional group, and finally naming the substrates. And for this also, naming substrates based on the alphabetical order. Numbering should be seen based on the functional groups, or the branches should get the least numbering. Okay, like it just stop here. You should be having that concepts also, that numbering should be selected from the such a way that the compounds which are having the branches, they should get the least number. So these are certain rules of by naming. And then if you go across another example, okay, so let us try to draw a few structure of this compound. Okay, so drawing the structure is quite very easy. First of all, when you draw structure, see the parent chain. Okay, pet, I'm not bothered about any other thing, just see the pet here, which means 5 carbons. 1, 2, 3, 4, 5. Done. Now give number 1, 2, 3, 4, 5. Numbering can be your choice. You can start from this side, that side, because you are drawing the structure. Now 3 hydroxy OH. Done. 2 pentanone. 2 pentanone. This is 2 is for bond. Means on second position double bond. Bond. Bond means ketone. Structure is done. What you need to do? Balance the hydrogen. That is the last thing. And for this, only thing you need to remember is valence of carbon. What is the valence of carbon? 4. This carbon bonded to 1, remaining is 3, CH3. This carbon double bond over, this side, 4 completed. It does not require any hydrogen. And for this carbon having hydroxyl group, 3 completed, 1 left. What is 3 completed? Carbon valency is 4. Carbon can be bonded to 4. So 3 completed, 1 is there, so CH. 2 completed, CH2. And 1 completed, CH3. Because a lot of students do mistake in this how to write CH2, how to write CH3. That is very simple. But it becomes simple when you first draw the carbons without any hydrogen. It will be very simple and you will never do mistake, because you know that what is the balance of carbon. You would be trying to write accordingly. Okay, so this is the basic way of drawing the structure. That is very simple. Make it quite easy. Don't complicate it. Okay, so let us take one more example, which will help you to write it in a proper way. Okay, so here 2-methyl 2-butene but 4 carbons, right? Fine. 2 methyl CH3 and 2 butene. Second, third carbon is having the double bond. Okay, done. Balance the hydrogen. CH3, 4 bonds, 1, 2, double bond, 4 completed. For this, 3 completed, double bond here, 1 there. So pending is 1. And this only 1 completed, CH3. Okay, so this is numbering you can mention. Like in exam, better to mention the numbering. It will be easy for the examiner to see that you are draw the perfect structure. So 2 methyl, 2 butene. Okay. Next is 2,3,3 triethylhexane. I think now you can easily draw all the structures. Okay. So this is the simple way. Whenever, because drawing the structure is much more easier than the writing the IUPAC. Okay, there you might be doing mistake, but when drawing the structure, you won't be doing much mistakes, because if you should follow the simple steps like taking down the parent chain, drawing it, giving a proper number, then identifying which position what is there, then it will become very simple to draw any structure. Okay, and next question is related to explain the term structural isomerism and classifying the structure. So I think this question has come earlier also regarding the structural isomerism. So you should mention about the various structural isomerism and what are organic compounds, classify them with structural example. Like what I have mentioned earlier, like regarding this organic compounds, like they have been classified into various categories. Okay, and then if you write these structures, then it will be enough for you to get the marks. Okay, so if you draw the structures perfectly, mention them properly, then you won't lose any marks. Like if you go towards this BPharm, after mathematics, only subject which where you can get cent% marks like 75 out of 75 or 100 out of 100, that could be organic, because here you can be like structure can be correct or wrong, but if it is correct, you will be getting the full marks. Like you might be getting only one structure, simple one line will be there, and it could be comprising of 2 marks. So that is won't be there in other subjects. You won't be getting that much marks. Okay, and here you can see like first 5 carboxylic acid IUPAC system of nomenclature for first 5 carboxylic acid, how to name them, common names of carboxylic acids. And then chain isomerism, it is very simple. It has been asked for 2 marks. So simply take, write the definition of chain isomerism, whether it is straight chain or branch isomerism, existing having the compounds having same number of carbon hydrogens, but they differ between whether the straight chain or the branch. Then you should mention with the example. You can take any example, simple example of propane and or butane. If you take 1-methyl propane, that is a most simple example. And here it has mentioned little again isomer has been asked, write the various types of isomerism with example. So in this is little bit I think it has been asked for 5 marks rather than 2 marks, where you need to first write about isomerism. You need to classify the different types of isomerism, then also mention about structural isomerism. So in this, I have more like detail you need to do. All right. So here, that's it about this organic basics you should be having to get perfect in this syllabus, like in this first unit. Okay, where we will be coming across naming systems, homologous series. We will be coming across. We will be coming across classification of various organic compounds, and then We have the concept of isomerism, where we have different types of isomerism. Okay, and like if you go towards deep for stereoisomerism, uh, to be exact, like it is a little bit vast concept comparatively, because in it you might be having optical isomerism. Again, you would be having a relative configuration. You will be having absolute configuration. Okay, so these concepts that are quite lengthy individually, they are quite a large concepts, which might be detailedly discussed in your further chapters. These concepts are quite vast, like stereochemistry itself, total different subject or total deep subject, where you need to study much detail about what is optical isomerism, how it occurs, what are the basic requirements to identify optical isomerism, what are the basic criteria for a compound to exhibit optical isomerism, what are enantiomers, diastereomers, properties of enantiomers, then the configuration parts that comes, like where we are having a relative configuration, where we are having absolute configuration. RNS comes under absolute, relative, DNL. Okay, DNL will come in relative, where we will be comparing with D-lactic acid and we'll comparing the other compounds. Okay, so that concept of stereoisomerism is quite vast, where we will be having an in-depth study of each and every category, specifically to optical isomerism. There are many things associated to this optical isomerism. All right, so coming to our organic chemistry. Okay, so we are having this Prakara. In this Prakara, we are having our first-year curriculum MLP, which is for only just 149 rupees, and that will be valid for 21 days. Okay, trial it will be there. Test paper, test pack will be there for each semester. Okay, so here it has mentioned about specifically for first years, you're getting all the subjects in this, where you will be getting video lectures, you will be getting student notes, you will be having the key terms and self-assessment with the help of tests and all. You will be assessed because after my session and all, you might be having a quiz related to your first unit, okay, which will be assessing you how much you might be having knowledge related to first unit. And if you are scoring very less, which means that you need to learn a bit more related to them. So these simple assessment tests will help you to identify at what position your preparation is there. Because BPharm after that, like every, like you might be having first year R22 syllabus has been quite modified. It has a different way of asking questions, like objective, subjective, and even in the final paper, you would be having three different types of questions, just not very short. You will be having a short answer and long answer. Three different type of questions that will be coming for R22. And even the passing marks has been higher comparatively, like 50% passing marks are there. So like the competition for R22 is becoming quite like the level of study and all has to be top class in order to get the good marks, and that can easily achieve if you get into this program where you can get registered with just simple 149 for each semester. Okay, so whole semester can be covered. So we are having for both the first semester also, we are having all the subjects covered, and even the second semester also, this whole subjects has been covered with the help of video lectures and student notes, key terms, and various things. We will be assessing you. We will be helping you to get the highest marks. Okay, so like when you understand the concept and learn, okay, that will you will never forget that. Okay, if you just by heart mug up anything, then it might be there only temporarily, because whatever you're going to study, it should have an impact. Like if you go towards this organic, uh, this chemistry is getting modified year by. Like if you go towards your syllabus, initially you'll be having organic chemistry, but when you go towards the second semester, second year, okay, onwards, second year, second semester onwards, the organic chemistry will get modified into medicinal chemistry. Okay, so if you're not thorough with organic, that will become more complicated for you. Okay, so these are connecting to each other. Okay, and this organic basics will help you a lot in understanding much more complicated drug chemical moieties, structures, and all these things are associated with this basics of chemistry. And for understanding in this, we have designed this easy way MLP program, which will help you to understand with the video lectures, with the various points like assessing points, which help you to easily get the concept. Like today, you got to learn about impact nomenclature. You might have knowing it, naming the structures and all, but how to name it in a simple way and how where you can avoid doing the mistakes you might have seen, and like bicyclic compounds nomenclature was also there. That is also a little bit appear to be complicated, but it is quite simple if you get the concept. Okay, so in such a way, these chemistry concepts we try to understand and try to identify how to easily, like they are like many tips are given related the drawing the structures and all. So if you keep those things in the mind, that will help you to get that chemistry becomes quite simple. All things depends on basics you should be having. If you just directly open the textbook and try to learn all the concepts, it won't be like it becomes total question mark. You won't be able to understand until and unless you might be knowing what it is. Okay, that can be known by having simple basic chemistry knowledge. Then it will become quite simple and understanding the concepts with the help of simple notes. Like we will be providing you a very simple way of learning that will help you to make it complicated things in a simple way, which will easily get and we will give you concepts in such a way that you won't lose marks as well as you will get the terms, get the concepts simply. Okay, because chemistry part, drawing the structure and whether theory part won't be much. Like the theory will be reaction itself is totally elaborative. If you go towards a simple example, it will be mentioning about how this thing is happening. Whole experiment is mentioned in a single line. Likewise, this organic chemistry compounds will also be in that way that whole lines will be there, and that will be mentioned in a simple. All right. Okay, that's it for today. Thank you.